Welcome to Algebra 1. The first question students ask in a math class is, why do I need this? Well, most people at the end wind up liking algebra. But to really understand why we need the subject, actually any subject, we must wait until we reach higher proficiency. For now, just remember this. You cannot excel in college without algebra. For algebra unlocks the mysteries of variability. And variability, of course, is the first topic we will discuss. A variable is anything that can change. For example, how many of us can go into a pastry shop full of different delicious sweets without changing our selections several times? Well, that is variability. Because you can't make up your mind, your purchase becomes a variable. Now imagine a supermarket where a company buys millions of different things. Without algebra, it would not be a supermarket because they would be limited by the number of items they sell. So, if we study things that vary, we will be able to predict outcomes, sort of like predicting the future, but with as little error as possible. For example, when selling donuts for a school event, if I say profit depends on cost and price, then profit will equal the price I charge for the donuts minus the cost of the donuts. Or, for short, profit is equal to price minus cost. If the school's principal tells me that I cannot charge more than the cafeteria, then the price I could charge is fixed. And because I can't change the price, to make the most money I have to buy the donuts at the lowest cost possible. Thus, the price will vary with the cost of the donut. If the price is 50 cents and the donuts cost 20 cents, the profit per donut is 50 minus 20 or 30 cents. If the cost varies to 30 cents, the profit is 20. If at 40, then the profit drops to 10 cents, and so on. I could see how profit increases or decreases by the use of a line graph. Notice that the line is straight, and because it is straight, we can predict the variability of profit at any cost by just matching axis values represented by the line. At 40-10, at 30-20, at 20-30, and so on. Now, in order to use variables, we need to learn how to turn simple English sentences into math expressions or equations, just like before when the price and cost was turned into profit. The examples that follow will get you into the habit of turning your own everyday quantitative problems into an equation or expression. By the way, a math expression does not contain an equal sign, while the math equation must have one. Also, the statement, a number, does not specify a quantity. So the English expression, a number, translated to math is X, or any other letter. From page 8 and 9, section 1.1 of the book, we start practice. Number 1. The product of 5 and 6 is 30. Because a product is an answer to multiplication, the answer is 6 times 5 equals 30. Notice that the word is translates to equal. Number 2. The quotient of 30 and 5 is 6. A quotient is an answer to division, and is means equal. So, 30 divided by 5 equals 6. Number 3. The sum of 3 and 4 is 7. A sum is the result of an addition. Is means equal. So 3 plus 4 equals 7. Number 4. The difference of 12 and 4 is 8. A difference is an answer to subtraction. Is means equal. 12 minus 4 equals 8. Number 5. A number. When we say a number, any letter will do. X, Y, Z, A, B, C. Normally, lowercase letters are used. Number 6. Twice a number. Twice would be 2 for twice, and X for the unknown number, or 2A. No other symbols are needed. Number 7. 4 times a number. Using what we learned in number 6, it would be then 4x. Number 8. 3 consecutive numbers. Consecutive means following one after another without interruption, like in 2, 3, 4, 5. If we call the first number, the one we don't know, x, then the number that follows must be one more, or x plus 1, and the next number, x plus 2. The answer is then x, x plus 1, x plus 2. Number 9. If 7 is added to a number, the unknown number is x, and we add 7 to it, x plus 7. Number 10. If 10 is subtracted from a number, take 10 from a number. Let's say n. n minus 10. Number 11. 8 less than twice a number. Take 8 from twice, or 2x. The answer is 2x minus 8. Number 12. 5 more than 3 times a number. Add 5 to 3 times, or 3x. Answer 3x plus 5. Number 13. A number to the 5th power plus 3. The phrase a number would be just x. To the 5th power, the exponent is 5. Then add 3. Number 14. 10 increased by half a number. Increase means addition. When we say half, we split in 2, or 10 plus x divided by 2. Number 15. The product of two numbers. If we say two numbers, the numbers must be different, like in x and y. Product is multiplication, so the answer is x times y, or xy. Number 16. The square root of a number decreased by 4. The square root means the radical sign, so this would be the square root of x, which we then reduce, or minus 4. Number 17. Pete is 3 years older than twice the age of Nick. In here, Pete is, and is equal. So P equals. Twice is 2 times. So P equals 2 Nicks, or P equals 2N. To this we add 3. 3 more years. P equals 2N plus 3. Number 18. Twice the sum of two numbers. By now you should know that twice means 2 times. Now, if you twice a sum, first you must add the sum, then multiply. This requirement is met by putting the addition in parentheses and the 2 in front of it. So 2 times x plus y is the answer. Remember, x and y are two different numbers. Number 19. 7 times the difference of two numbers. In 7 times we multiply times 7. But before we do that, we establish the difference of two numbers, x minus y. So x minus y is in parentheses, times 7. Number 20. 3/4 a number reduced by 6. 3/4 is the fraction 3 over 4. Of a number is 3 over 4 times x. We then reduce it by 6. 3 over 4, x minus 6. Number 21. 5 is to 6 as 10 is to 12, a proportion. 5 is to 6 is the fraction 5 over 6. And 10 is to 12, the fractions 10 over 12. The word as in a proportion represents the equal sign. To complete the proportion, 5 is to 6 as 10 is to 12. Number 22. The sum of two numbers squared. The comma before squared means that the addition must take place first. Then we take two different numbers, x and y, add them, put them in parentheses, and square them as a sum. Notice the 2 in the exponent means square. Number 23. The sum of two numbers squared. There is no comma here, so we square first, then add. No need for parentheses. Number 24. Mount Everest is higher than Pico Aconcagua. Higher means greater than, and greater than is the arrow towards the lower number. E is greater than A. Number 25. David scored at least as high as Pedro. At least as high means that it cannot go any lower, but always higher. So we use the sign greater than or equal to. D is greater than or equal to P. Number 26. Sandra earns less than Francis. Because it is less, the arrow is directed towards the lower quantity. So Sandra is less than Francis is S is less than F.